we are looking at volumes of similar shapes. In volumes of similar shapes, again, we shall be considering the ratio of volume of a bigger shape to volume of a smaller shape. Remember, that ratio of bigger and small gives us our constant square, constant cube. K will always stand for constant, and it will be representing the length of the bigger shape over the length of the smaller shape. Now, remember, we can short form the volume of a bigger shape to just V1, volume of a smaller shape to just V2. Therefore, we shall take our formula as V1 over V2 is equal to constant cube. Don't forget, K represents the ratio of length of a bigger shape over length of a smaller shape. Hence, on the place of K, we can keep L1 over L2. And the formula which we shall concentrate on a lot will be V1 over V2 is equal to L1 over L2 cubed. But do not forget that this formula comes from V1 over V2 is equal to K cubed. Now, let's look at the first example. You can see we have our solid shapes, 3D shapes. One, we are given its volume and the length of one side. The other, we are not given the volume and we are given the length of its side. Now, we are supposed to find the volume of this shape. Now, when you look here, this is the smaller shape, this is the bigger shape. Now, since these two shapes are similar and we are given the volume, we shall consider V1 over V2 is equal to L1 over L2 cubed. Remember, up, most of the times, we shall keep the bigger volume, down the smaller volume, up the bigger length, down the smaller length. Our bigger volume in the bigger shape is V. Our smaller volume will be 60. Hence, we shall keep V up and 60 down. Our bigger length will be 15. Our smaller length will be 7. Hence, we shall keep 15 over 7. After doing so, we shall open the bracket where 15 will be cubed and 7 will be cubed as shown. After that, we shall get the value of 15 cubed, that is 3,375. Also 7 cubed will be 343. After that, we shall cross multiply. 60 will go over to where 3,375 is, and we shall get 60 times 3,375, and the answer we shall divide it to 343. And finally, we shall get the volume of the bigger shape being 590, and our units will be centimeter cubed. Now let's look at the second example. Remember, on the first example, we found the volume of the bigger shape. In the second example, we are going to find the length of the smaller shape. If you check closely, we are given the volume of the bigger shape, and also we are given the volume of the smaller shape. We are given the length of the bigger shape. We are not given the length of the smaller shape. Hence, we are now finding the length of the smaller shape using the same formula. Volume up, volume down as shown there. Length up and length down as shown here. Remember, this is over. So, we shall expand by opening the bracket. That will be 100, will be 1,000. This will be 1,000, and down will be x cubed. Shall cross multiply. This will go over that side, and the 80 will go this side. We shall get this statement. After doing so, we shall divide 320 both sides, and we shall have x cubed is equal to 250. To get x, we shall have to cube root 250, and finally we get 6.299 etc, which will round off to approximately 6.3. Now, this is how we shall find volume, or we shall find length of the side when we are dealing with volumes of similar shape. Remember, V1 over V2 is equal to K cube, where K stands for L1 over L2, giving us V1 over V2 is equal to L1 over L2 cubed. But don't forget, the formulas with K cube are very important. There are some questions which we cannot solve until we have those constants. And the most important place where we need to use the constant is in the question where it is not related to length of sides. You might have a question which is connecting area and area, volume and volume, and we do not have length of sides. We shall need these formulas. At the same time, you have to remember, the K in the area formula is exactly the same as the K in the volume formula. This K is the same. What does it mean? If I can find the value of K in area, I can just substitute it in the K of volume. Let's look at one example. When you look at this example, we are given area of a smaller shape and also area of a bigger shape. We are given volume of a smaller shape, but we are not given volume of a bigger shape. Remember, we are given volume of a smaller shape. We are not given volume of the bigger shape. But when you look closely, you will find that we are not given any length. Therefore, we cannot use the other formulas which involve length. Now, what shall we do? When you check, on the smaller shape we have area, on the bigger shape we have area. This means the proportion of area is given on both sides. So, in this specific question, we can find the value of K using the two areas as shown here. Area 1 over area 2 is equal to K squared. Now, area of a bigger shape is 60, we keep it up. Area of a smaller shape is 15, we keep it down. When we divide the 2, we get 4. And then when we square root 4 is 2. Hence, we shall know our constant value is 2. Now, remember, we have one volume, we don't have another volume. Therefore, we are going to find the second volume. How? The constant we have got, we shall replace it in the K of volume, as you can see there. Hence, volume of the bigger shape is V, we shall keep up. Volume of a smaller shape is 40, we shall keep down. But remember, the other constant K, which was 2, is now cubed. Why cubed? Because the volume formula. So 2 cubed will be 8. So now we shall have V over 40 is equal to 8. When we cross multiply, 40 will go to the side of 8. Hence we shall have 8 times 40 to give us the value of V. And finally, the big volume now will be 320 centimeter cube. Remember, we found it using these two formulas because we did not have any length given. Do not forget that in another similar question, you will be given volume, and you will not be given one area. What does it mean? You will use the two volumes to first find K, then you take the formula for area, substitute the K, and get the value of one of the area which is not given. Thank you for watching. My name is Mr. Ishengoma. If you enjoyed the video, you can like and subscribe to my YouTube channel. Thank you.